Hello student, in this video I am going to discuss about, as I have already told you that I am going to discuss about this points, normal distribution, binomial distribution, Poisson distribution and exponential distribution, which is included in the course plan also. Basically for today's video I'll go through only two, that is normal and binomial distribution. So first try to know what are these distributions. So several specific distribution commonly occur in a variety of business situations. So here you can see that we are dealing with the business problems, but you can think this distribution can occur at various type of field also. So normal distribution is actually a continuous distribution characterized by a asymmetric bell-shaped curve, and second one, that is binomial distribution, a discrete distribution. So here you can see the first difference is that a normal distribution, a continuous distribution characterized by a symmetric bell-shaped curve, and binomial distribution is a discrete distribution that is relevant when we sample from a population with only two types of members, or when we perform a series of independent identical experiments with only two possible outcomes. So here we are dealing with two class, or we can say binary class problem. Here we are trying to find out two class, or we are experimenting a series of independent and identical experiment, and this distribution is discrete and relevant when we sample from a population of with only two types of members, means two class of members, and after we apply a series of independent identical experiments with only two possible outcomes or two class outcomes, so then only we can draw this binomial distribution. Next one is Poisson distribution, a discrete distribution that describes the number of events in any period of time. So a discrete distribution, Poisson distribution, is like a discrete distribution that describes the number of events in any period of time. To describe the number of events in any period of time, we can use Poisson distribution. Exponential distribution, a continuous distribution that describes the times between the events. So here you can see which ones are normal, which ones are exponential. And exponential distribution, a continuous distribution also, and that describes the time between events. So if we go to a normal distribution, the single most important distribution in statistics is the normal distribution. It means it is highly used and widely used. It is a continuous distribution and is the basis of familiar symmetric bell-shaped curve. Any particular normal distribution is specified by its mean and standard deviation. So this normal distribution is the concept revolves around the mean and standard deviation. By changing the mean, the normal curve shifts to the right or left. So here you can see one context with this normal distribution is that if we change the mean of the data, or if we can change the mean of the data, then the normal curve, the general normal curve, shifts to the right or left. By changing the standard deviation, the curve becomes more or less spread out. Means if we reduce the standard deviation, then it will be more, the data will be more around the mean, and then spread out will be less. But if the standard deviation is high, then data spreading of the data will be higher, and that is why the shape will be like more spread out, and those data will not be more closer to mean. there are really many normal distribution, not just a single one. Normal distribution is a two-parameter family where the two parameters are the mean and standard deviation. So basically, in basic sense, normal distribution can be parameterized by two value or two variable, that is mean and standard deviation. For continuous distribution, instead of a list of possible values, there is a continuum of possible values, such as all values between 0 and 100 or all values greater than 100. So here you can see this is a continuous distribution. Normal distribution is a continuous distribution, and that is why what happens is that we create the values in a range or in a category, but values will be in continuous. Like here you can see such as all values between 0 and 100 or all values greater than 0. So that range specifies a range. That value specifies a range, but any values in that range or outside that range or inside that range. So instead of assigning probabilities to each individual values in continuum, so instead of assigning for every values of that range a probability, the total probability of one is spread over the continuum. So here you can see we know that probability 1 is means total probability, so that probability of 1 will be spread over that range whatever we take. So because in that range the values are continuous but not discrete, that is why for any value we cannot take a specific specific probability value. We will take a distribution of probability or distribution of or will spread the one all over this range or continuum. The keys to spreading is called density function. So how will this distribute or spread over that probability 1 over all data in a range is defined by using the density function, which acts like a histogram. But histogram is basically a discrete type behavior, but density function provides same type of concept like histogram, but density function provides a spreading, or it provides that like the higher the value of density function, the more likely the region of the continuum is. Suppose for 0 and 100 any values, suppose in the range of 40 and 50 the density function is high, then we can say that in that region the numbers of values are more higher, or the events of occurring in that range is higher. So higher the value of density function, the more likely this region of the continuum is. Means we might take 0 to 100 range, but if we give some density function and the value is higher at some specific region like histogram, then we can say that though in that region the values are more, or that region of the continuum is more likely. Here you can see a density function usually denoted by fx. Suppose this is a function of x, specifies the probability distribution of a continuous random variable x. So continuous random variable x, so try to understand this. This is continuous random variable x and function is fx to find the density function. The higher the fx, the more likely x is. Here you can see higher the fx in this region is higher density. So you can say the higher the fx, the more likely x is. That x be in that region is more likely, but the x be in that region is less likely. So the total area between the graph of fx and the horizontal axis, which represents the total probability, is equal to 1. So here this is 1. This is the total probability. The total area between the graph, so whole area of this graph is 1. Fx is non-negative for all possible values of x. That is a property of fx, properties of density function, that it is non-negative and for all possible values of x. Probabilities are found from a density function as areas under the curve. So probabilities will be areas under the curve. So then probabilities are found from a density function as areas under the curve. Here you can see, if you zoom in this point, here you can see area under the curve. Area under the curve is probability of being between 65 and 75. So this is the highest probability. So density function also in this region is high. Here you can see again, the normal distribution is a continuous distribution with possible values ranging over entire number line from minus infinity to plus infinity. Though we think that here is this, we say that the whole area describes the total probability 1. That is why here it is saying that it is a continuous distribution with possible values ranging over the entire number line. Number line is this line. Number line is this line. Okay. So minus infinity to plus infinity. So that spreading is not likely to end up in a specific point. That might go for infinity. That is like minus infinity to plus infinity. So only a relatively small range has much chance of occurring. So here you can see only a relatively small range has much chance of occurring, means higher the region of density, that area has the higher chance of occurring. The normal density function is actually quite complex in spite of its nice bell-shaped appearance. Though you can see or you can understand what is this density function, if you go through the main function of fx, you will find it more tough and it is actually complex. If we go through this equation, you will find it. Okay, here you can see the formula for normal density function, where mu and sigma, mu is the mean, sigma is the deviation, are the mean and standard is here. You can see how it is related, but it is a bit complex. But you can remember this, or you can apply this to find out the density functions. Okay, here is 1 by twice pi sigma into e exponential of minus x minus mu whole square divided by twice sigma square, and that value of x is between minus infinity to plus infinity. So that is the equation. Try to remember it. So the standard normal, there is a one point is the standardizing. So the standard normal distribution has mean 0 and standard deviation 1, so it is denoted by n01. So why? The point is that here it is saying that this standard normal distribution has mean 0 and standard deviation 1, so it is denoted by n01. It is also referred to as z distribution because the general normal distribution has higher complexity to find the density function. That is why they try to put this mean and standard deviation as 1. So the name is like standard normal distribution, or we can say as z distribution. To standardize a variable, subtract its mean. We need to subtract the mean and divide the difference by standard deviation. Then the value we'll got is a standardized variable, and if we plot those values of that variable, we will get a z distribution. A z curve is the number of standard derivations to the right or left of the mean. So here you can see, if z is positive, the original value is to the right of the mean, and if z is negative, the original value is the left of the mean. So what it is saying, if we apply the z standardizing, or if we apply the z distribution, and if z is positive, if it becomes positive, that z, then we can say the value is to the right of the mean. Obviously, because if it will become negative, only x is lower than mean or x is higher than mean. If z is negative, then it means that x is lower than mean. If it is lower than mean, then it will be in the left of the mean. Original value is left of the mean. If it is positive, then we can say that x is higher than mean, and it means it is right of the mean. So you can follow through this example where we can standardize the value. Okay, this is the original value, this is z value. Calculate two different ways. The second the second with the standardized functions. So data set includes the annual returns of 30 mutual funds. Calculate the mean and standard deviation of each annual return, and then use the standardizing formula to calculate the corresponding z value, or calculate z value directly using Excel standardized function. So there is two way. One is you can calculate using the function, or you can use the standardized function of the Excel. So you can try it on Excel. Okay, so a common use of z values and standard normal distribution is calculating probabilities and percentiles by the traditional method. So here you can, the use of these z values and the standard normal distribution is to calculate the probability and percentiles by traditional method. So rather than using traditional method, using the z value also we can calculate the probability. Okay. The method is based on a table of the standard normal distribution. Here you can see this method is based on a table of standard normal distribution found in many statistics textbook. You can find it. A example of such table is given below. The body of the table contains probabilities. Body is probabilities. The left and top margin contain possible values. So if it is 0 0 z values, then you can go for this probability. Okay, it means around the mean, complete mean, but it might be negative. Okay, so you can find this type of z value table with any statistics textbook. So 001 means 0.5040. So two types of calculations are typically made with normal distribution, finding probabilities and finding percentiles. The functions used for normal probability calculations are norm dist. This is norm, not norms. This is norms, norms in inversion actually. So you can use these functions in Excel actually. So try to go through this. Normal calculations, objective to calculate probabilities and percentiles for standard normal and general normal distribution in Excel. Standard normal and general normal. For less than probabilities, use norm dist directly. For greater than probabilities, subtract the norm dist, the norm function from 1, like that. Norm dist and norms dist. So we, for percentage calculation, use the norm mean, or this. Try to use this. Okay, you can find that thing. So there are three empirical rules apply to many data sets. About 68% of data fall within one standard deviation of the mean, and 95% fall within two standard. That is also discussed in few videos ago. Because that is in empirical rules, that is the empirical rule, 68% of data falls within the one standard deviation of the mean, the 1 times the standard deviation. 95% falls within two standard deviation, and almost all fall within 3 standard deviation, means thrice of the standard deviation. For these rules to hold with real data, the distribution of data must be at least approximately symmetric and bell-shaped. That is why this is normal distribution. So next one is binomial distribution. So binomial distribution is a discrete distribution that can occur in two situations: when sampling from a population with only two types of numbers, males and females, suppose example to class, and when performing a sequence of identical experiments, each of which has only two possible outcomes. So two outcomes and two samples, two data samples. Consider a situation where there are n independent identical trials and where the probability of success on each trial is p and probability of a failure is 1 minus p. So suppose you want to check that that having a value in two class, so it will occur in either class. If it occurs in a class A, then it will not occur in class B, but if it occurs in class B, if it will not occur in class A. That is why if you try to understand the probability, consider a situation where there are n independent identical trials where the probability of success on each trial is p and probability of failure is 1 minus p. So define x to be the random number. So here x to be a random number of success in n trials. So here x to be the random number of successes in n trials. Then x has a binomial distribution with the parameters n and p. So this distribution has two parameters, that is number of possible trials or trials p, number of possible trials p, and number of independent identical trials n. So n is the number of independent identical trials and p is the success trials. In that n number of trials, p is a success number of trials. So this distribution revolves with this parameter. So suppose you can use same thing in the Excel also. You can go through this slide, I will give it to you, and try to use these things in Excel. It can be shown that the mean and the standard deviation of a binomial distribution with parameters n and p are given by the following equations. So here expectation of x equal to np and standard deviation of x equal to square root over np 1 minus p. The empirical rule discussed in chapter 2 in previous videos and also apply at least approximately two binomial distribution. There is about 95% chance that actual numbers of success will be within two standard deviation of the mean. So here also we can say that 95% of the chances of occurring of success will be within twice the number of the standard deviation, and there is almost no chance that number of success will be more than 3 standard deviation from the mean. So if sampling is done, so binomial distribution in the context of sampling, if sampling is done without replacement, each number of the population can be sampled only once. So each member of the population can be sampled only once, so it should not be overlapped. So that is why this should be independent. That is, one person is sampled, her name is struck from the list and cannot be sampled again. That is why this is independent. If sampling is done without replacement, then it is possible, although may not likely, to select a given member of the population more than once, and that might lead to dependency. Most real world sampling is performed without replacement. So in most cases of the real world cases will be taken as without replacement, so that those sampling is independent. The binomial model applies only to sampling with replacement, but the binomial model applies only to the sampling with replacement. However, if more than 10% of population is sampled, then the binomial model can be used safely even if sampling is performed without replacement. So here you can see, if 10% of the population is sampled or more than 10%, then we can go for without replacement, means no dependency, complete independency. But if it is less than 10% of the population, then we might go for replacement, then only binomial distribution will work. So here you can see in this graph, This is discrete graph. If you graph the binomial probabilities, you will see an interesting phenomenon that the graph begins to look symmetric and bell-shaped when n is fairly large and p is not too close to 0 and 1. So here you can see p, that value p will not close to zeros and 1, and n will be fairly large. The normal distribution provides a very good approximation to the binomial under this condition. So here you can see the binomial distribution and normal distribution look like similar, but this is the binomial is discrete and normal is continuous with two parameters, like n is the independent events and p is the successive events. One practical consequences of normal approximation to the binomial is that empirical rules apply very well to binomial distribution. So the empirical rules of the normal distribution also apply on binomial distribution if we now take the normal approximation to the binomial. So if the n is fairly large and p is not too close to 0 and 1, then we can apply this normal approximation to the binomial and it becomes look like a normal distribution. So you can find out these problems, you can follow this problem with the Excel and through this slide you can find out how it gone through. Okay, you can find out this calculation, how can we find out the solution of different objectives. Okay, these are homework, try to do these problems in Excel or in any other platform for your understanding. And we'll discuss Poisson and exponential distribution in next coming video, and that is why before that try to go through these problems, actually try to understand these concepts of binomial distribution and normal distribution using different examples. You can go through the Excel and you can apply the provided functions here, and you can go through these objectives and problems to find out the solutions, how it is saying and how we can do the things with this normal distribution and binomial distribution. And if you have any doubt or any question, please ask me. That is all about in this video. Please let me know if you have any doubt. Thank you.